Okay, thanks, Chip. This is Brian Bowden from Greenlight Group. Let me just forward through some slides here to get to mine.
There you go.
So I want to take a small amount of time today to go over a technical overview of how we took application Syslog data and put it into OBA Operations Bridge Analytics for dashboarding. So the customer use case, we have a large financial customer. They had IBM data power data in their Syslogs that they needed to get into OBA to do dashboarding for transactions per second and average transaction time. They had a large volume of lines per day within their Syslog. In production, they're running about 35 million lines per day in their Syslog. And the required data for their dashboard was set across multiple lines within one transaction within the Syslog. So there were 17 lines of Syslog data per transaction, and we needed two different lines to build their dashboard the way they requested. So how did we do that? We first we took the data power data and we had it forwarded to our Syslog server, and on that Syslog server we were using the Micro Focus OA agent 12.04 version to do log forwarding to OBA, and we were using the generic output for structure log file policy to do the filtering of that data and to provide that data to OBA. It has to be in a certain format, so that policy does that. And in the 1063 version, OMi 1063 version, that policy actually starts allowing us to use some filtering that wasn't available in previous versions. So due to the amount of Syslog messages that we were receiving for each transaction, we had to find the URL and the transaction latency lines, which there were just the 2 lines out of 17, as I said prior. So once we have all the structure log file policy set into place, and we were able to assign variables for the transaction ID and other pieces of the Syslog data, we were able to then forward that to OBA using the log forward policy. And the actual filtering is done on the log forwarding policy, not the structure log file policy, because there is no way to do suppression within the structure log file policy. So I included a slide here with my syntax for that policy. I'm not sure the level of experience with these log file policies, but just to give a little overview, on the data source tab, you can set up what your standard portion of the log message is. So in this case, it's the date and time and the host name for the log that it came from and the severity. And the rest of we've moved into a variable called rest of the line. And so then we could use that rest of the line within the rules tab to be able to assign variables to the data and then take that data and assign it to field names, which then get passed on to OBA. And so we're forwarding all 35 million lines of data to the log file policy. But on the log file policy, you're able to discard on unmatched or matched or forward data to the next step to OBA. So what we decided to do is we discarded on unmatched, and we decided anything with a transaction ID or the variable transaction that was greater or equal to 1, we would pass it through. And that would mean that that was one of the lines that we actually assign the transaction number variable to. And then we also forward everything that comes out of that. If it has a host name of data power, which we hard-coded in the schema tab, it's highlighted in red on the slide, that will also gets pushed off to OBA. So in the end, we went from 17 lines to 2 lines of data, one line including the URL, one line including the latency of the amount of time for the transaction. So once that data gets put into OBA, it gets put into the ops collection message table. I started to work with AQL and XQL queries to join that data together so we could provide it to the dashboard. come to find out that there's a limitation within OBA that your data has to be on the same row. So we had to come up with a solution to get around that. So my first solution was to just create a table within the database, create a script to join the data and insert that into the table. Well, we came into another problem that OBA doesn't allow for AQL queries against tables that are not created by OBA. So we had to come up with another solution. So moving forward, we use this opsa-custom collection script that's on the application server. Within that script, you can build a table. You have to provide your column names, your data types, and all the different things you want to put into that table. And once that's created, it actually comes through as another integration. Within the source type manager, you can see the name of it when it's created. So that allows OBA to be able to query against that table to build the dashboards. So on some of these, I didn't mention it before, but on some of these slides, I actually include the documentation. There's a link to the documentation on this slide for creating the custom collection table. So once we had the table set up, we had to get the data from the original table to the secondary table, which we just did within an insert script where we did a join of the two multiple lines in the custom or in the ops collection meshing table. Excuse me. And then there was another table we had to create where we compared some data of source. So they wanted that to be done. So I've included that script here on this slide, and we're running the script every minute. We're using OMi schedule task policy, and I've also included the command that we're using to do the update or the insert into the database. If you notice, there's two different inserts within the script. The first one grabs the data, joins it together, compares it to another table, joins that data together also, and then inserts it. Well, we found that the secondary table that we created, the customer was supplying us with application names according to their IP addresses, and their list wasn't complete. So I built a secondary insert table or insert syntax to insert it in as null if the secondary data is missing, and then we have an update that anytime that it is found to be null, that we update it to unknown. So that allows us to actually dashboard against every transaction, even if we're missing some of the data. So once we get the data in and we can start doing the queries for building the dashboards, then we can customize to whatever the customer wanted. So I'm not able to show the slides because or a picture of that because it was customer related, but I just wanted today to go through the steps that we took from receiving the data in the Syslog to using the OA policy to filter that data forwarded into OBA, and then how we made that data available for the dashboard. So my last slide here is just a couple lessons learned that I learned along the way. Due to the size and the amount of messaging coming through on that Syslog, we ran into a limitation on the OA agent that there's a 2 GB limitation on the log file. So once the log file hits 2 GB, then it stops with the silent fail of forwarding data to OBA. So I got around that by using log rotate, and I included the link to the instructions on how to set that up on this slide. But I rotate it every day. Plus, then I watch for the size of the file every hour. And then the second thing that I learned the hard way actually is when you create a custom collection table, you do not assign a column with unique data in it as a key field, because OBA keeps track of those key fields. And what happened in our case was that it started to add an entry into entity.index table every time a message came through, and so it became very large, and it caused big performance problems with OVA. So just keep that in note. It's not a required field. It's the key field that OBA is watching for on each transaction. So that's the end of my presentation. And if you have questions, feel free to send those in. But just a quick overview of how we took data from a large amount of data from Syslog and we made it dashboardable in OBA.
Thanks, Brian.